A GATE 2015 question on first law of thermodynamics is solved. The problem statement is given. You can read. Schematic of this problem is given here. There is a gas inside an insulated container. A stirrer is rotated 1000 times and hence stirring work is done on the system. System here is the gas within the container. Due to this work done on the system, there is a change of state, and what is the final temperature? That is what we need to find. Data given: mass of the gas m, initial volume v1, Cp and Cv values, initial pressure P1, number of times the stirrer rotates, the torque on the stirrer are given. We need to find the final temperature of the gas. Due to thousands, due to 1000 rotation of the stirrer, the gas undergoes a change of state. It is plotted in a TS diagram like this: initial state, final state after 1000 rotations of the stirrer. Due to the rotation of the stirrer, the system has undergone a change of state. Therefore, for a closed system undergoing a change of state, first law of thermodynamics is dq equal to du plus dw. The container is well insulated. The first line of the problem statement gives. And this is the insulation. Since it is insulated, dq is 0. That gives du equal to minus dw. Du is the change in internal energy. It is expressed as mcv dt, and dt is T2 minus T1. M is the mass of the gas. C suffix V is the specific heat capacity at constant volume. We can write minus dW equal to mCv T2 minus T1. M given in the problem. CV data is provided. T1 data is not given. T2 our aim. DW is not given. Therefore, in order to find T2, we need to find DW and T1. After that, we can substitute in this equation and find T2. How to find DW and T1? Shaft work is 2 pi nt. N is the number of rotations, T is the torque. Both are given in the problem statement. Substitute 2, value of pi, 1000 rotations, 100 is the torque, 10 power minus 3 is to convert the resulting joule into kilojoules. So 628 kilojoules. And ideal gas equation is P1 V1 equal to mRT1 when applied to state 1. From this, we can find T1. So the equation is rearranged like this. P1, V1, M and R are given. What is this R? R equal to Cp minus Cv. Cp is given as 1000, Cv is given as 800. Therefore, R equal to 200 joules per kilogram Kelvin. Substitution of the variables. When substitution of the values of the variables gives T1 as 500 Kelvin. Now, already we discussed mCv T2 minus T1 is equal to minus dW, and this dW is nothing but the shaft work, because the only form of work transfer involved in the problem is stirring work. Stirring work is nothing but the shaft work. Why it is minus dW? Because work is done on the system. Stirrer is doing work on the gas. You can substitute the known values. Mass is 1, Cv is 800, T2 we need to find, T1 500, shaft work minus 6 to 8, 10 power 3 is to convert kilojoules into joules. This yields T2 equal to 1285 Kelvin.